So let me get ourselves started. So we have our oops. So this is our panel. So good evening, good morning, and we'll start for our panel. So our panel is called From Coding Agents to Pedagogy Agents. I think right now, this year, is the most popular term, agents, right? So we covered pretty wide spectrum. So in our panel today, I'm a Xiangen Hu. I'm from Hong Kong Polytechnic University. I'm the moderator, and we have three speakers. We have Richard Tong from IEEE co-founder of NeoLab, the sound that you just hear. And we have John Stamper from CMU. He's going to talk about the agents stuff. And we have Professor BaoHui Zhang from Shanxi Normal University. So the order is going to be Richard Tong goes first, John goes second, and BaoHui goes the last. Now, if you guys leave some time for me, I will talk. Otherwise, we call for the day. Okay? So Richard, you get started.
Okay, let me share again. Once I leave that share. Can you see my slide?
Yes. We see your PowerPoint, but not the slide, trying to play. Okay,
Yeah.
that's it. Okay.
Okay. Yeah, so today it's actually, I'm going to talk a little bit about this new paradigm where, again, from the coding agent to pedagogical agent, but in this framework called symbiotic intelligence for computer science education, right? So the discussion is that we created this new paradigm called AI plus X learning paradigm. So there's some core concept, right? So there's the basically uh, we are kind of like converting from the learning about AI to learning with AI, or learning use AI as tools, and rather as learning as using AI as partners. So So we want to actually establish this new thing where coding is becoming a so-called cognitive dialogue between the agents and the student. And in this paradigm, the AI plus X paradigm is not just AI plus computer science, but AI plus everything. Could AI plus math, AI plus physics, AI plus business or accounting, or all these. So in all of these courses, we established this framework where there are three core learning objectives. In the past, we're learning only about this first thing, which is we call the disciplinary knowledge. But in this future, we're talking about both the disciplinary knowledge and also the AI collaboration skills, basically working with agent to learn, to produce, to work, and it's kind of like a new cover-all competency that need to be learned along with the disciplinary knowledge. And also the third dimension is what I call the metacognitive competence, which is basically the way that you can think, you can ask critical questions, you can do judgment, you can learn how to learn how to adapt, and also learn how to work with both people and also AI in a collaborative way. So this new paradigm is basing on a so-called representation. We call the K-star representation. Actually, we have a new word for this. It's also called functorism. It's a new rhythm similar to the connection with connect. Oh, what is the George George's connectionism, right? I mean, I couldn't spell the word, or behaviorism or constructionism, but this is a new way we call this functorism. Basically, what we say is that in the future, all the learning and all the knowledge can be represented in this new symbolic representation called K-star. So basically what K-star is that it means that any knowledge can be coded as these 5 things. So basically we say any knowledge or any experience can be encoded as at a certain situation in order to accomplish a certain task, the capability to generate action plan and then execute those actions and getting expected result, both forecast and getting result, and then compare the expected result with the actual result and getting the feedback into learning. So this is the whole, we think any knowledge, whether it's human knowledge or agent knowledge or animal knowledge, could be encoded in such a way. And we use this one to bridge the gap between neural knowledge and the symbolic knowledge or agentic knowledge, right? So that's the foundation for this paradigm. And in the way that we're talking about like computer teaching and so forth, we have different roles for the agent in this paradigm. We have teacher agent, mentor agent, two agent, and all these different agents, but they are doing things in different stages. So you can see here, there is the agent that captured the K-star knowledge, and then especially pedagogical knowledge. So the agent are encoded with the, kind of like pre-instilled with some knowledge that can be used to teach. But then students also capture this knowledge through this experience to knowledge cycles. And you can see here, hold on. Why did it jump so much? So again, so this is, we're talking about the different knowledge stored at different stage. And the knowledge that we're saying is that we actually use a particular class as example to go with today's flow. We're using a computer science class as an example to illustrate how our new paradigm in this new AI Plus X program will be taught differently from a traditional course. We use a computer science course. This is from Stanford CS 106A, which is their introduction to, like computer science, the very, very basic one. And we implement this at CS University, which is our launch partner, in both in the spring and also this semester to implement this course, which is a different, it's teaching basically the same disciplinary knowledge, but taught it very differently. So we're basically saying, okay, we want to instill the computational thinking and all these main learning objectives for this computer science class. However, we're teaching that differently, right? So we're talking about there's 3 different dimensions. So you still have the original dimension, the disciplinary knowledge, the second dimension, which is AI collaboration dimension. The third dimension is metacognitive reasoning dimension. So those 3 are going to be taught hand in hand together. So this is kind of like a typical syllabus. I'm not going to the details, so it's very easy to think about. But the way that we teach it is different, right? So we teach it in a way that every class is going to be divided into 3 stages. Actually, so let me see. Hold on. So here, actually, I have a video, but I don't know whether I have the time to play that. Let me see. Let me kind of like quickly just launch that video. Hold on. Can you see my screen still?
Yes.
So today we're going to talk about a pretty radical new way of looking at teaching and learning, and it's all powered by AI. And we're not just talking about using AI as another fancy tool. We're talking about a future where it becomes a real, genuine partner in the classroom. Okay, let's just start with a big question. Imagine for a second, what if education wasn't this one-size-fits-all, one-to-many lecture? What if every single student had their own personal tutor, their own coach, available anytime, day or night, totally customized to how they learn? Well, that's the whole idea behind this new educational model called AI plus X. And it's a really fundamental shift, you know? We're moving away from just teaching students about AI and diving headfirst into a world where they're actually learning with AI, side by side, every single day. And at the heart of all this is a concept called symbiotic intelligence. Now, this isn't just about using a calculator or a spell checker. This is about a real partnership, a team where the student and the AI are learning and growing together, and each one is actually making the other smarter.
Now, to really get why this is such a game changer, we first need a benchmark, right? We need to understand what the gold standard looks like today. And for that, we're going to use Stanford's famous Intro to Computer Science course as our comparison.
Look, Stanford's CS 106A is a world-class course, no doubt about it. But it follows that classic structure we all know. You've got the instructor giving a lecture, you go off and work on problems by yourself, and you get really good feedback from a real person, but it often comes days, maybe even a week after you've already turned in the work.
Okay, so now let's flip the script. A pilot program at SciS University is reimagining this entire process from the ground up. They're embedding AI directly into every single step of the learning experience to create that symbiotic model we were just talking about.
So this new model is built on three main ideas. First, you still got to learn the subject itself, the core knowledge. But just as important, you learn what they call AI collaboration fluency. Basically, how to be the boss of an AI, how to work with it effectively. And the third pillar, which is so crucial, is developing metacognitive competence. That's a fancy way of saying you learn how to think about your own thinking. You learn how you learn. So how do they pull this off? Well, with a whole team of specialized AIs working in the background. You've got a teacher agent that helps the human instructor design the course. Then you have the mentor agent. Think of it as your own personal Socrates, always asking you guiding questions instead of just giving you the answer. And finally, you've got the tool agent, which is like your hands-on coding partner, right there in the trenches with you.
Okay, so that's the theory. But what does this actually feel like for the student in the chair? Let's do a direct head-to-head comparison, because the changes go really, really deep.
First off, the whole vibe of the classroom changes completely. It stops being a passive lecture hall where you just sit and listen. It becomes an active, hands-on studio where you learn by doing, and you're constantly bouncing ideas off your AI partners.
And this is a huge one. The feedback loop, which is everything in learning, shrinks from a week down to a single second. Your mistakes aren't something you find out about later. They become these immediate little opportunities to learn and fix your course right there, in the moment. And it's not just the classroom, it's the tools themselves. They're not passive anymore. Your whole coding environment becomes this active ecosystem of AI assistants that you can direct to help you figure things out, debug problems, and just solve things in a much more powerful way. So when you put it all together, you can really see the massive shift here. The student's role goes from just being a listener to being an active co-creator and AI director. And the human teacher? They evolve from just delivering content to becoming a learning orchestrator, kind of guiding this whole amazing human AI dance. This creates a totally new rhythm to learning. Before class, you've prepped with an AI textbook that already knows where you're struggling. During class, you're in that hands-on studio applying what you know. And then, after class, an AI coach helps you reflect on what you did, solidifying what you learned about the subject and about yourself.
All right, this all sounds pretty amazing, right? Almost revolutionary. But it's not that simple. We really need to take a balanced look at both the incredible promise here and some of the very real dangers.
On the plus side, the promise is just huge. We're talking about genuinely personalized education for every single person on the planet. That means deeper engagement, less frustration, and maybe the biggest thing, it produces people who are already fluent in the #1 skill for the 21st century, human-AI teamwork. But, and this is a big but, the challenges are just as real. There's a serious danger that students could become way too dependent on the AI. Then you've got huge hurdles like cost, technical complexity, and of course, major concerns about data privacy and the potential for these AI models to be biased. And this quote really gets to the heart of it all. The goal isn't to replace human thinking, it's to augment it.
It's about creating graduates who can use AI as a powerful partner, not as a crutch that does the thinking for them.
So, to actually pull this future off, it's going to take a lot of care. We're going to need smart rules to manage the risks, a total focus on making sure students are always in the driver's seat of their own education, and, of course, a deep commitment to ethics and privacy.
And all of this leaves us with one last big question to think about. As we move into this future, where we're all learning and working alongside AI, what becomes the most valuable human skill? Is it having all the answers, or is it having the wisdom to ask the right questions?
Okay, so I'm done with that part of it. So let me see, come back here. So you can see, well, I already talked about this whole thing, and I think you have a good kind of like a understanding of what this does and so forth. There's the good comparison between our approach versus the traditional approach. And the advantage, as the AI already talked to you, so we're talking about this instant feedback, one-on-one coaching all the time, and the latest and greatest capabilities. And most importantly is that this skill is going to be what you need as a computer science graduate. When you go into the workforce, you will need to work with these AI agents in order to produce. I mean, using your bare hand or bare kind of like a brain to code is going to be the path, right? So it's just like when people are moving from from the horse cart to cars and automobiles. If you only know how to run or how to ride a horse, it's not going to cut it when everybody is driving cars, right? So that's the part of, and also I want to just jump in a little bit in terms of the standard that we're promoting again, because as I'm the chair for the AI standard committee for AI for IEEE, and we produce a whole bunch of standards that could help along with these, including the agent interface standard that currently we're developing, and the agent for education standard, large language model agent for education standard P3428. And we already pretty much finished the P2807.6, which is the education knowledge graph standard to basically putting all the ontology around a course or on a curriculum together. And also we have the xAPI, which is the experience data tracking to track all the learning events and do analysis. And also the competency framework that defines reusable competency and skills so that this can be compared and then evaluated. And definitely the ethical and privacy standard that are involved. So yeah, so these are my part of the talk. Thank you. Sorry, I overused maybe 2-3 minutes.
Okay, thank you very much. I think we're going to leave some questions at the end. So, John, this is the panel. There's no need to have a PowerPoint. I think we don't have to use PowerPoint. John, feel free.
Thank you. Yeah. So, I'm John Stamper. I'm an associate professor of human-computer interaction at Carnegie Mellon University, and where we're thinking about agents and how to use LLMs. Actually, can I share, Richard? Yeah, thanks. We've been thinking about this from the idea that, and kind of following off of what Richard said, that students need to really understand how to work with the AI. And it's pretty much a given now, especially at the higher ed level. And we've also found out at the K-12 level that 100% of students are using generative AI to do their homework and their other work. So what we've been trying to do is figure out how we can help students engage with the AI in a productive way. And we're calling that pedagogical prompting. And so how do we teach students who are going to be using AI anyway, how to do it in a way that will help them with their learning in the best way? And then from that, we've actually learned how to really create these pedagogical prompts. We've been turning those into what we're calling pedagogical agents, which are then suited to help the students do some of the tasks that they can offload, with the recognition that, again, we only want to offload the tasks that are extraneous, that the students already know how to do, right? We just want to scaffold the parts that they know already with the agents to help increase the efficiency of learning the other things that they don't know. Let me share real quick here. So we built this intelligent tutor to actually teach what we're calling pedagogical prompting. And with this tutor, we're showing the student these scenarios. And in the context we're working right now is in CS1, Computer Science 1 kind of courses. But we're applying it to other courses as well, including a course in physics and a course in chemistry. But we give the student a scenario where, in this case, David is reading his homework problem and his task description, and he's having a lot of trouble getting started. And then we kind of explain what the different, the typical student response to this is to go to ChatGPT and said, my code doesn't work, and paste their code in there. And, ChatGPT, is surprisingly good, and the other ones as well, Claude and the others, are surprisingly good at correcting code, but not necessarily helping them understand. So we've developed kind of this context of what a pedagogical prompt is, where the learner needs to really specify what they need, the context of the task that they're doing, and trying to understand what is the problem that the student is having. And so, they can go through, I'm not going to go through the entire thing here, but let me show you. So essentially, this is the scenario where the student is really having trouble getting started. And so what we're trying to do is kind of scaffold the help seeking. So using a lot of the help seeking literature that already exists, what type of problem are they having? Is this an understanding problem, or are they having a debugging problem, or are they having trouble writing the code, finding the next piece? And in this case, it is they just don't even know how to get started. So it's really trying to understand the task description, and then we ask the student then to write in the prompt, and we can give them feedback in here, and then they go through. And there's a bunch of these different scenarios which help them try to get through and learn this process. And then in this process, these are also the process, the different agents that we've built now. So, we try to figure out whether the student is at a planning task or it needs a debugging, what kind of help, and we can create these agents then to scaffold those individual parts of it. Just real quick, let me add, one of the other things we're trying to do is create a system to help folks build agents faster. And some of you might be familiar with my former work with LearnSphere. So LearnSphere is a analytics tool that lets you build analytic workflows, and you can share those workflows. We're actually building an agent builder on here, and if you go to the LearnSphere site, we actually have a link here where you can sign up. We're going to open up the beta pretty soon. If you're interested in getting access to that, there's still some cost issues and how to tie the various agents together that we're working on. But we're going to open this up, and we have a bunch of different components like, text to video and video to text and question generation. And we've built these kind of components that you can then string into the various type of agents. And then we also have some standard agents that we've built for things like help seeking and other things. But yeah, if you're interested in that, you can go to the learnsphere.org and sign up for the agent builder beta. And I'll stop there.
Thanks,
muted.
John. Yeah, that's great. So let's, I'm gonna have some questions at the end. Okay? So BaoHui, are you ready? You can share a slide. So I invited BaoHui to talk about the software agents and the pedagogical agents that have been used in China. So he has been very, very active in the field. So go ahead then, BaoHui.
Okay, so can you see my slides?
Yes, yes, yes.
Okay. I'm very excited that to join this community and to learn from all of you when you are doing the programming and develop the applications like Professor Hu has showed me. And he even has quite some agents to help him to do the programming. And just now, I thank Richard for showing us the song made by AI, and also I look at Zhang, and later I can make a connection to your experience. So I'm from Shanxi Normal University, and from Xi'an, China. One of my doctoral student, Mr. Yuan Zijian, he helped me to prepare some of the slides, and the registration for this conference is full, so he couldn't join this Who or Zoom platform. But right now I'm sharing my screen with him as well with another digital video conferencing system. So I talk a little bit about the title and what I understand for the pedagogical agent, and a little bit about myself, so that I want to convince you that we made a wonderful team, and then I present that some results that I searched just today, and show some of the pedagogical agent applications in education in China briefly. And you can see if you paid attention to the terracotta warrior and horses, that's Xi'an, that's where I'm from. And right now I'm a professor in educational technology, but I was a high school teacher to start my career. So in this panel, I think I'm the person that tried to let you know that what is needed by me as a classroom teacher and now a teacher educator. Right now that I moved from a chemistry teacher, then chemistry teacher educator, and then to a professor in educational technology, because I thought educational technology could help that students learn that faster and deeper and those kind of things. But I want to tell you the truth. I'm a bit disappointed that to move to this educational technology area, because I see very few applications that last very long, that has fundamental impact in classroom teaching and learning. And I can mention some of that, and some colleagues like knowledge building, like UC Berkeley, Marshall Lin's group, but very few that can last long. And when I was at Nanyang Technological University in Singapore, that I worked with people from computer science, and I heard that as a computer science professor, if you have a project, you have new ideas, you don't have to make the full programming that function like for the end user. You might, some new idea, you just have a prototype, and you showed people how did you do the programming, what is the theoretical foundation, and then the prototype works, then you can publish, and you will be promoted. But I appreciate all of you to work with learners, for learners, because when you do that, and you have to be responsible for the end users. So I really appreciate the idea that to have a pedagogical agent let's see that one of these definition it says it's a virtual character and used in online learning environment that to help to promote or student learning to serve as a learning tool. But this has been changed today. Like Richard mentioned that the paradigm change that right now it's not learning about AI, it's learning with AI. And I really appreciate that idea. A pedagogical agent that can be a coach or a mentor or tutor or learning companion. And I don't feel that I can give it a specific order. For example, when I was a doctoral student, I learned from Professor Chen Tai-Wai, and his PhD dissertation was about learning companion. So it's been that at least 30 years. And right now we are still pretty much saying that a learning companion, like a human. And so the agent that we can know that it's really not just a tool. However, we look at the pedagogical agent for education in China. I searched in the largest database that has education literature that in Chinese, and you can see I only found 23 results, mostly are journal papers, and you could see that in just last year there were only 5 of that. And this year it was predicted that there could be up to 15 papers in this area. But we still can see that this is still something new in China. And later I can show you more about the information about those papers. And the reason for this jump, I want to say that this tied to a Chinese government initiative. Right now, I heard from Richard and Zhang, you also talked about AI Plus. And in China, we used to have Internet Plus, which was 9 years ago and promoted by the government. And now we have this called AI Plus for many fields, including that education area. So that might be the jump. And I think for me, I'm still learning a lot. And I'm actually feel anxious today. I hope that what I say can be that well aligned with what you're doing. For those papers that we see distribution of the themes, and you see that agents or education agents or application in instruction or big model or look at the future and education application. So basically, I want to say those papers that they are either introduction from for international literature or to explore that in theory and and if you look at the distribution in subject areas, and it's really that it's scattered. That's what I can say. And computer science, and then education theory and administration, and then at middle school level. So these are the 3 that with the percentage that okay the most that or the most popular that subject areas. And if you look at the papers, whether in applied research or development research or technology research, well, it's only a few of them, so I wouldn't say more about that. And here is interesting. And you look at the where the papers were published, and you can see that so many of them, and some are journals to public research papers, some are just for to kind of advertise the AI use in education, and the levels, the quality varies a lot. So you can see the varied. So we can know that this is still very new in regard to applications in education in China. And if you look at the papers themselves, and this one, it has been downloaded a lot, and it's relatively new, 2021, and the citation is 57. So all I'm saying is this area is still new, although that educational application of those technologies has been a long history, and we have so many universities that to have that educational technology programs. So to wrap up for me is first, I want to have the good AI applications. When I see that is, I have concerns with AI in education right now. I say that maybe the benefits are less than the are less than the risks, because for the big data and for things that in a database, they are not reliable, and there's just so many problems of them. So I hope that when we have this meeting, when we discuss the applications, that we think about the learners. So I think I'm going that from the two sides to come together with some of you, because you are the people to realize the ideal situation to help student learning. And I'm the people to say, hey, that's what I need, that what difficulties that I have encountered as classroom teachers or as the collaborators of them, and what we need. And I let you know, try to make the technology work. So with that, whether Internet Plus or AI Plus, so my point to wrap up is let the learners, let the users to have the final say. And thank you.
Okay, thank you, BaoHui. So we're gonna
Yeah.
have some questions asked those applications in China.
I
So I
try
have
to.
yeah, if you can stop sharing, then I will
Right.
start a brief presentation of mine.
Sure. Thank you.
Okay. So I'm going to have about 5 minutes or less presentation, and then I will show, and then we're going to have discussion. So the title of this one, From Coding Agents to Pedagogical Agents, is actually, I proposed this panel because I'm actually building an application. Okay, so here's what of course, this is what we have, and then here's an application that I'm actually writing, and this is not vaporware. This is actually working right now. So for those of you actually want to see, I will show you. But basically what I have is this entire application, I use code agents to do it. Okay, I have 3 levels. This is competence-based. This is curriculum-based learning. This is competence-based learning. And then this is each of the 3 modes. So here you have a knowledge explore, basically it's like a passive reading, passive learning. And this is the tutoring called the Socratic playground. And here's adaptive testing. So each one of those are in this form. So this is too small. No need to worry. After this, if you want to see the application, I will share with you. So this is reading. This is actually the tutoring, and this is adaptive testing. Okay, so all those are controlled by this. It's actually, I have 26 agents that actually behind this software. I use this one to this actually. You can see this is if you can see, this is actually a team of sub agents. Those are 26 of them. I just find every single one. I say, go ahead and run, design my finish my program. After about 10 hours, get everything done. I have a great taste of how software agents will make it work. If those of you do not have this taste, I highly encourage you to try it out. You're going to be amazed what software agents or what agent will do for you. Okay. And then, for example, this is the application here. We can go back, and then all those things are actually done. Dashboard. I go over here, and then so this one here. This is actually this is the competence based, and then you can see and then if I go over here, and this one actually goes to this one here, and then make you read, and then like a charm, works like a charm. So actually go over here, you actually can do interactive reading, and you expand, and this give you everything. Okay, here we there. And of course, if you use others, you can go to the tutoring system and others. We can show later if anybody wants me to do. Okay. Now, this is being done by software agents, 26 of them. This is organization, and then I use Cloud 4.5. It's just does it, it's claimed that they can continue to do the program for 30 hours. For me, 10 hours is enough. Now, this is another agent. I have 57 ITS agents. Those 57 agents actually do the recommendations. For example, if I click here, this is the agents. This is the 57 agents. I will show you if I have time how do it work. So if you click here, it's actually launch different levels of recommendations. Say, okay, now I want you, I will let you. Well, my app says, okay, now I have 5 different levels depending on how much time you want to wait. Okay, if you wait longer, I can use all 57 agents and process your data for you and make recommendations. Okay, and also if you click on every single one of them, this is actually the core 30 agents and this 27 extended agents. If you click on there, actually give you exactly how each one of the agents. What is the input? What is the output? What is the input data from? Where the data is sending to? Remember, this is an ITS. They work with each other. So here, this is actually the level 3 workflow. There are 20 different agents, and this is the core part. This is the extended part. Every single one of them specify exactly what data they're getting from, where it's sent to. Okay, and then this is the pedagogical agents. In other words, everything work together that actually suggest or actually dictate the true teaching agent, how you do, what kind of scenario is given, what kind of hint is given, so on and so forth. So that's basically the run through. Okay. So anybody want me to show you how this worked?
Yeah,
okay,
definitely.
Very, very quick. Very quick. So for example, in this case, so I'm going to go here. If I go to the dashboard, okay, this is a student. Okay, this is a student, and this is one of the course over here. Okay, competence-based course. If I select one, if I select this one here, there is 3 things to set. This is a recommendation. If I click here, and this one says which level you want me to recommend. So the default is level 2, and they're all the way to 12 levels of 5 to 57 agents. Okay, so this one is going to take longer. For example, if I click here, and this one was view the workflow, this is exactly how the system is going to work for. Let me see. Here is the level 3, about 20 agents. Okay, this one says exactly where the input come from, where the input is sending well, and the sending. And if you do this, you say continue, is actually coming back with recommendations. Okay, if you click here, this one actually says, oh, this agent going to recommend what tutor going to do. This is recommendation, and this is the level, and so forth. And in this case, it's recommended me to do knowledge explorer. So if I click here, Now this one goes to knowledge exploration. Okay. So, and then now if you go over here, in this case, so you can go. So for I can this is actually introducing the content, and you go over here, and then you can go to each go to further competence, or you can specifically go over here and say I want to have a this one called interactive reading. So you actually can read this one here, goes to specific vocabulary, and then talk about it. And the AI going to explain exactly what the definitions are, and also you can say, hey, I'm 12-year-old. Don't get this. This is the one. And also you can say, oh, I want this one to be expanded. This one expanded is actually go to expanded version, and you can actually type some additional here. So this give the system prompt, and here give you a custom prompt. If you go in, so now it's actually started generating this expanded ask questions about those. Okay, so that is the one. And then of course you can have others. So you can go to go back and then do other modes. Okay, so this is actually the application for how this 57 ITS project work. I actually have a paper. So for any of you interested in how does 57 ITS agent work together and when the data come from, this is about 46-page paper that you feel free to to ask me for it. Okay, so thank you very much. We have 10 minutes for questions. No questions?
I mean, I think let me kind of like pose a couple of questions, right? Okay.
Okay.
One thing is about the roles of the teacher, right? So in our platform, I think the roles of the teacher has changed quite a bit, whether it's in higher ed or in K-12. I think when we're talking about these agents, like you have the 57 agent in all aspects of the learning journey. But how does the human teacher, or in this case, between the human teacher and the human student, how do they coordinate all these agents, right? Because it's a pretty complex process, especially like in our program, we have the before class process, during class process, and after class process. Where does the human and the this army of agent, how do they coordinate together, right? I think those are kind of like a very delicate dance that you have to orchestrate or choreograph, right?
Yes. Let me also comment about where the humans are, right? So here's something that I always want to do, or trying to do. So when we use when we talk about learning, there are three different kinds of learning or different levels. One is foundational learning. Another one I call transformative learning. The third one is social emotional learning. Everything I talk about this one more like foundational learning. Okay. This does not mean that you're going to replace a human. The human do transformative learning. There's something that knowledge that have not been digitized. For example, your teacher's personal experience, your life, stories, the impact that you have that AI cannot do. So that's one. In other words, that part is called transformative. Another thing is social emotional learning, where you actually learn from each other human. Okay, how do you divide them? How do you divide them? Right now, of course, we can say, well, there's something that if it's my lecture, I do my lecture. If it's not my lecture, it's something common knowledge, you just use the AI. Now, in the future, probably a policy, what is allowed for the AI to do lecture and what is not allowed. Now, I want to say this because I see a lot of technology-oriented professors say, okay, I want this one to use AI, but actually, it's not the AI that cannot do a good job of answering. It's whether you will allow AI to do the answering or not. I'll give you the following simple, very intuitive example. If your child, your daughter, and your son ask the first question, what is meaning of life? Even your uncle is not qualified to answer this question. You're the one that answered this question. It's not like your answer cannot answer a question better than you. No, you are entitled to give the first message of those important to your child. So in other words, it's not like when a human in the future that whether a computer can do it or not, is whether we as a human allow computer to do that or not. Right now, the smartest AI with IQ 148 probably outsmart every single one of us. It's going to answer questions better than us. It's not like they cannot answer. It's whether we really allow them to answer or not. Okay, so that's my answer. Where's the human going to be there? It's not like you cannot do better than AI. It's like you do not want AI to do your job. Okay.
Yeah, I think as long as we're talking philosophy, one thing I worry is, are we at this pivot point where, there's going to be less and less human generated content and human adding to the knowledge, and because AI is just regurgitating everything, that, there's going to be the amount of content being created because of these agents is massive, and it's going to just add and add content, but it's just regurgitated content. And is there new content being added and new knowledge discovery? And yeah, this is a worry I have, but yeah, anyway, I'll leave it at that on the philosophy side.
I have another question. This is for Zhang, because I think what you earlier talking about, you want to use the AI to delegate only the thing that the student knows how to do, right? I think that, but on the other hand, this is actually a broader question, is that, first of all, in this new paradigm where agents are participating in these teaching and scaffolding and all these, where does the assessment lead us? How do we assess the student skills? So for example, if a student graduated and knows how to do vibe coding and create really beautiful applications, do you think that they should be allowed to pass the exam and also getting the computer science degree? Even if they haven't, like a lot of the web coders, right? They don't know anything about a particular language. Like when I'm coding, like in Apple, I have not learned Swift. I have not learned Object-C, right? But I can use my Claude Code and generate beautiful Apple app. Do you think that I can pass the exam?
I will say this is something we're encountering at Carnegie Mellon and talking about, and I can honestly say at CMU, no, you would not pass right now. But is that the ongoing answer down the road? I do not know.
But will someone hire me though?
I don't know. Yeah, I suspect they would.
Okay, George is
you might be missing the end stuff. Yeah, you might be missing stuff, but yeah.
Sorry to force it. I have another room that's waiting.
Okay.
And
Yes.
so this has to end to jump into there. So apologies for this. Right. It's been a fantastic session, and I look forward to sharing the recording with everyone. So thanks all. And just getting into a meaty discussion. So I apologize.
Thank you.
Yeah,
Thank
for those of you who want to have
you.
a link or something, just get in touch with me. You probably can, if you cannot track down me, then the AI is not going to be helpful, right? You can track me down. Okay. So thank you very much. I think this is very productive. And then good night for those of you in China, and good evening or good afternoon, good morning in where you are. Okay.